Travelers to the Pacific Northwest are witnesses to a mystery that puzzled geologists for decades. A maze of enormous empty canyons. Huge dry waterfalls with incredibly deep plunge pools. House-sized boulders bounced from their moorings like stream cobbles. And giant ripple marks the height of 3-story buildings. All are seemingly water-created features, all of a magnitude beyond anything known on Earth. Yet they lie hundreds of miles from any major body of water. In 1923, geologist J. Harlan Bretz proposed a theory for these bizarre landforms. A flood of cataclysmic proportions, greater than any flood ever documented from the geologic record. But his story seemed too fantastic, one the world was not yet ready to hear. Floods of a different sort were known to have occurred in the region. Over millions of years, floods of molten lava poured across western Idaho, eastern Washington, and Oregon, building layer upon layer, thousands of feet thick. As the lava cooled, it tended to shrink and crack, forming vertical columns of basalt. The volcanic fires were followed by the deep freeze of the Ice Age. Little more than 15,000 years ago, the continental ice sheet crept southward into the Pacific Northwest. A finger of the ice sheet reached into the Idaho Panhandle, blocking the mouth of the Clark Fork River. It created an ice dam half a mile high, and as water backed up into the deep mountain valleys of western Montana, it began to form an enormous lake. Lake Missoula stretched for hundreds of miles and was at least 2,000 feet deep. It contained 500 cubic miles of water, as large as some of today's Great Lakes. At 2,000 feet, it was deeper than any lake in the United States today. Faint shorelines etched into the mountains above the city of Missoula, Montana, show that even that far east, the lake was nearly 1,000 feet deep. No other glacial lake has been so deep against its dam. No glacially dammed lake as large as Lake Missoula has stood so high above the country downstream. But the ice dam could only temporarily restrain such an immense volume of water. When the water reached its maximum depth, it burst through the ice barrier, shooting out of Clark Fork Canyon at a rate 10 times the combined flow of all the rivers of the world. At that rate, the lake would have drained in as little as 48 hours. As the water raced toward the ocean, it reached speeds in excess of 65 miles per hour. This mass of water and ice literally shook the ground as it thundered across the countryside. The roar would have been audible for at least half an hour before the flood struck. The floodwaters carved out over 50 cubic miles of earth from western Montana to the Pacific Ocean. Entire sections of the rolling Palouse Hills of eastern Washington were quickly transformed as up to 200 feet of soil were stripped away down to the underlying lava bedrock, scouring it into a rough scab-like surface. Deep channels or coulees were gouged into the bedrock in a very short time because it was easy to pick the basalt apart, column by column. The flood currents were so powerful and so turbulent, they were able to pluck out and transport blocks of basalt more than 30 feet in diameter. Unlike normal river valleys, these scabland channels were full clear to the brim. They overflowed their tops, cutting an intertwining canyon network. Satellite photographs of eastern Washington reveal not the tree-like branching of a normal drainage system, but that of a braided streambed. Only this streambed is more than 100 miles across. This braiding and the channels themselves are so totally out of proportion with the landscape that only from space is it possible to comprehend their massive scale. The largest channel of all, which by far carried the greatest volume of water, was the Grand Coulee. At the site of the Grand Coulee Dam, another finger of the continental ice sheet blocked the Columbia River Valley, forcing water over the rim of the valley. Just 20 miles south, near present-day Coulee City, the water poured over a steep hill, the tilting basalt of the Coulee monocline, forming a waterfall 900 feet high. The waterfall retreated upstream as it undercut its lip, leaving behind a gorge 20 miles long, up to 6 miles wide, and 900 feet deep. The Upper Grand Coulee is probably the world's finest example of a receded waterfall gorge. But during the peak of the flood, it was the Lower Grand Coulee that boasted the largest waterfall in the world, 3.5 miles wide and over 400 feet high. What is now known as Dry Falls, if it were flowing today, would dwarf Niagara Falls. Water at least 300 feet deep shot over the lip of Dry Falls at speeds approaching 65 miles an hour. Because of the extreme volume and velocity, there was probably only a slight dip in the water surface at Dry Falls during the height of the flood. The flood currents did slow down in powerful eddies behind bends or outcrops in the channels, depositing huge gravel bars. These mountains of gravel are almost as high as the coulee walls themselves. The Great Gravel Bar of Moses Coulee is over 3 miles long and as tall as a 30-story building. As the flood escaped the channels, the water spread out and dropped much of its load, debris so large it can hardly be called sediment. Monstrous boulders weighing more than 200 tons are scattered randomly over thousands of square miles. Many of these giants actually floated in, embedded in icebergs that went aground as the flood subsided. Nowhere else in the world have boulders this size been transported by water. The raging torrent could find only one outlet to the ocean, through Wallula Gap. This narrow bottleneck created a gigantic backwash that completely reversed the flow of the Snake River, sending a towering surge of water rushing upstream for over 100 miles. The floodwaters stalled behind Wallula Gap, forming a vast temporary lake nearly 1,000 feet deep. Once beyond Wallula Gap, the flood tore through the Columbia Gorge with incredible force, ripping away soils 1,000 feet above the valley floor. The extent to which the floodwaters widened and shaped the gorge is uncertain, but the spectacular cliffs and waterfalls in the gorge testify to the work of tremendous forces, to which the floodwaters undoubtedly contributed. Released from the confines of the gorge, the flood swept far south into Oregon. Much of the Willamette Valley was drowned under the floodwaters, and water levels reached 400 feet where Portland stands today. Boulders from as far away as Montana and Canada, rafted on icebergs, were stranded throughout the Willamette Valley at the high water mark. The scouring continued all the way to the ocean and beyond. Sea level has risen since the last ice age, but out near the edge of the continental shelf, under 300 feet of water, an ice age canyon several hundred feet deep is still there. Lake Missoula, all 500 cubic miles of it, was gone. But the continental ice sheet continued moving south and blocked the Clark Fork River Valley again and again, creating other Lake Missoulas. In fact, layers of flood sediments indicate that from approximately 15,000 to 12,800 years ago, these floods occurred repeatedly, dozens of times. In spite of all the seemingly obvious signs, widespread acceptance of the floods would not come until the discovery of one key piece of evidence. In the Camas Prairie of western Montana lie a series of rather unassuming, long-rolling hills. It took a leap of imagination and the advent of aerial photography to see them for what they were. From 5,000 feet up, it was as obvious as taking a walk on the beach. They were ripple marks, giant ripple marks, 30 feet high and 2 miles wide. The deep waters of Lake Missoula, traveling 60 miles per hour as the lake drained, had created these ordinary formations on an extraordinary scale, so large that they would seem to belong more to the realm of science fiction than to reality. Yet once they were recognized, many other sets of giant ripple marks were identified throughout the flood path. The great floods left a lasting mark on the land and on those who now follow its distinct footprints. Today, we drive roads conveniently routed through flood channels, grow crops in rich flood-deposited soils, recreate in sun-drenched lakes, gaze at beautiful waterfalls, and supply cities with water from expansive aquifers, all products of these earth-changing floods. The mystery has been solved. J. Harlan Bretz indeed discovered what must have been the most spectacular geologic event to occur on our planet during the Ice Age. He stood alone for over 40 years, insistent that no other explanation could account for the region's unique geology. In the end, he left us with a new understanding of catastrophic events and a humble sense of the magnitude of the great Ice Age floods.